All right, the constant rule. The derivative of a constant is 0. That is, if c is a real number, then d dx, remember that means take the derivative of c, means of a constant, is 0. Always, always, always. We kind of talked about that because if we have a constant function, that means that's a horizontal line. The derivative, which is the slope of a tangent line to that horizontal line, is 0. Why? Because the slope of that line is 0. Well, let's prove it real quick. Let's say f of x equals c, some constant. Well, we know how to find derivatives using the limit definition, so let's do that real quick. Good practice for a Tuesday. All right, we know the limit definition. Limit. You guys want to go h goes to 0?
Yes.
Okay. F of x plus h minus f of x all over h. We know that's the limit definition of the derivative. Okay, so we have the limit as h goes to 0. What is f of x plus h? If f of x is c, is there an x anywhere to substitute x plus h? So let's just see. Minus, what is f of x? C. All over h. And then we have the limit as h goes to 0 of 0 over h. What's 0 divided by h? And what's the limit of a constant? The constant. And there we go. In my writing of this, I think I forgot one thing. You guys know what I forgot to write down? Yeah, f prime x. Yep, I should have said f prime x equals, right? All right, so the derivative of a constant is always 0. Always, always, always memorize it, okay? You do not have to use the limit definition of the derivative to find it. Just know it, unless we actually say it, right? Let's use that constant rule. If y equals 7, what would y prime be? 0, yeah. What's another way to write y prime or the derivative of y? Do you remember? dy dx equals 0. Okay, remember that? All right, if f of x equals 0, then f prime of x equals 0. If s of t is negative 3, then s prime of t, did I say negative t? No, negative 3. S prime of t, well, that's a constant. This is where everybody gets hung up. If we are told that k is a constant, k is a variable within our function, well, y equals k times pi squared. Pi is a number also, right? Pi squared. So we have constant times number, so number times number squared. That's going to be a number. So this is a constant. This whole thing is a constant. And so what does y prime equal then? 0, yeah. Okay, questions on that? All right, there's our constant rule. Let's look at the power rule. Now to do this, what we're going to do is we're going to break it up and we're going to find some derivatives using a limit process. All right, row A, what'd you guys get? You guys got 1? That's what I got. Row B, you guys wrote it all out? Got it all? 2x? Row C, row D, you guys wrote it all out? Use your math muscle. X plus h times x plus h times x plus h times x plus h. Or use Pascal's triangle. Anybody use Pascal's triangle over there? Yeah, no. E, what'd you guys get?
1 over 2.
1 over what? 1 over 2 root x. That's what you got after you multiply everything out? Okay. This also equals 1/2 times x to the negative 1/2 also. Okay, you could write it like this. This is more, this is preferred. This one is preferred also for F. I worked on F right here. I did the fraction one, the scary one. Okay, what's the pattern, guys? You guys see a pattern? So drop down the exponent and then subtract 1 from the exponent. Does that work for all of them? That's it. That's all it is. If you have base x raised to a power, then what you do is you take that power, drop it down in front as a multiplier, subtract 1 from the power, and that is it. Mr. Bond, does that work for negative powers? Yes. Does that work for fraction powers? Yes. All right. Based on that rule, what if f of x equals 3x to the fourth, what is f prime of x? 12x to the third. Yeah, the 3 is a multiplier. 4 times 3 is 12. Subtract 1 from the power. There you go. If f of x equals, say, x to the 1/4 power, what is f prime of x? What? And then there's other ways of writing this that you guys have learned in the past, right? The 4th root of x cubed. The problem is we have to be able to rewrite functions or expressions so that they look in this form. So we can take the derivative. All right, real quick, let's find the derivative. 3x squared. Okay, what is g prime? Whoa, how'd you get that? Say again? This is negative third power? Ooh, so what we need to do is something called the classic rewrite. We need to rewrite our function so it looks in that form. Okay? X to negative what? Okay. And then obviously, okay, well, 3 is in the bottom. That means go downstairs, negative exponents, right? So it'd be a 3rd root of x squared. Okay, how about letter C? Is this any form at which we can apply the power rule? No, you got to make it that way first. So rewrite. What? Just negative 2?
Well, x to negative 2.
Say what you mean. Okay, now what? Y prime or dy dx is equal to? Okay, negative powers mean you can go on the opposite side of the fraction bar. Okay, so different variations of the same answer. Are we okay with this power rule right now so far? Okay, basic. Rewrite so you can apply the power rule, rewrite so you can apply the power rule. All right, now we're going to do the same thing we've done before. That's nice about calculus because we're going to learn a quicker way of doing something. Then we'll apply the same concepts with this quicker way of doing something. Okay, find the slope of the graph. Well, what's the slope of the graph? It's the derivative evaluated at some x value, right? Okay, find the slope of the graph of f of x for f of x equals x to the fourth. All these 3 different values. All right. First of all, let's just find the derivative. And that would be, all right, so that is the slope of the tangent line for all x values, right? Well, let's just plug in 3 of them. All right, we're going to be specific and write down what we're doing. We're finding the derivative, which means the slope of the tangent line when x equals negative 1. And negative 1 to the 3rd power is negative 1 times 4, negative 4. All right, how about f prime 0? Would be, so what can you tell me about that tangent line that has slope 0. It's horizontal tangent line, right? And then x to the 4th, let's go when x equals 1, so f prime of 1. That's just 4. Guess what we're doing next? Write the equation of the tangent line. Okay, write the equation of the tangent line. What do we need? We need point, we need slope. How do you find slope? Derivative. How do you find point? F of that x value, right? F prime x equals 2x. Okay. F prime of what? Well, it said -2, so f prime -2. And what is -4? Slope of the tangent line. Okay, so we have slope. We have the slope of the tangent line. Well, now we need a point. Well, they gave us an x value. How do we find a y value? Okay, f of -2. And that would be -2 quantity squared. And what was that, -4? All right, so our point is -4, slope is -4. And then, yes, point slope form, please. Y minus 4 equals -4 times x. We do +2, right? Okay, so this is good. And I think we know what the alternative form would look like. Leave it like this. Just leave it. They might have a couple multiple choice answers that are listed as slope intercept, but just leave it like that. Yep, so when I ask you guys to write the equation, write it here and stop. That's all you guys got to do. That's much quicker than using limit definition of the derivative, isn't it? All right, how about this constant multiple rule? What happens if there's a constant in front? If we have some function that is c times f of x, bring that constant multiplier out in front and multiply that by the derivative. And what does d over dx mean? You take the derivative. Or you can say the derivative of f of x, yeah. Now I'm going to break things up maybe a little bit more than we really need to, just maybe to help you guys visualize what's going on. This could be 2 times 1 over x, right? So now we have our clear constant multiplier times our function 1 over x, okay? And I think we need to rewrite this before we can use the power rule, can't we? And this would be 2x to the -1 power. Okay, now we have our function rewritten so we can apply a rule. We're going to find the derivative, and y prime then equals, well, the constant multiple rule just says write down your 2 and then multiply by the derivative of x to negative. Normally, we just take the derivative. But right now, I'm just going to write it out maybe once or twice. That's what's actually happening. 2 times, okay, the derivative of x to -1. Well, drop down your power. Subtract 1 from your power. 2 times -1 is -2. X to the -2 power in the top means x squared in the bottom. They want us to take the derivative. Well, we can do that. D dt this time of f of t. Mr. Bond, you can take the derivative of both sides? Yep. Just did. What's the derivative of f of t? Well, f prime t. Okay, we have a constant multiplier, 4/5. That can go out in front. Just like we did with limits, right? Okay. This is the derivative, but you haven't done anything yet. It's like leaving it as square root of 4. Actually do the square rooting now. Okay, actually do the deriving now. 4/5. The derivative of t squared is, okay, and arrow up. It means f prime of t. What is that, 8/5 then? Oh, if you want to put the t up top, that's fine. 8/5 t, 8t over 5, either way. What should we do with c first? Rewrite, yep. We're going to be using that word rewrite a whole bunch, guys, because we're going to have to rewrite things so they're in a form which we can apply rules to. Again, that's just algebra. Okay, d dx of y equals d dx of 2x to the half. Well, what is d dx of y? You can say y prime, or we could say dy dx. 2 can go out in front. Again, I'm kind of overdoing it a little bit to demonstrate this rule. And it's kind of like we need to know how these two are equal, just different forms. We need to know that all this is equal, just different forms. Okay, 2 times, what would that be? 1/2 x to the negative half, right? We're subtracting 1 from the power. Two times half, that's 1. And then x to the negative half means x to the half in the denominator. Or we could say 1 over root x, and no need to rationalize, folks, for me right now. We could if we wanted to. Okay, go ahead and do letter D and E, please. Big caution also, rewriting is not taking the derivative. So be careful with that. So what would be the rewrite for letter D? I'll write the 1/2. X to the what? Well, x squared to the 1/3. Well, I'll say negative 1/3. Now, rewrite again, because we don't know how to do this one yet. This is called the chain rule. We don't know how to do that yet. We have 1/2 x. Well, power to power is multiplying powers, right? Negative 2/3. Okay. This is always going to be your numerator, and this is always going to be your denominator. That's one way of looking at it also. And it's in the denominator. So then we need to move it up. So then the power will be negative. Okay. So y prime then would be, or dy dx, okay, 1/2 times what? All right, there's our derivative. Now simplify, rewrite. Okay, y prime. That would be what? Negative 4/6, which is what? Negative 2/6, which would be negative 1/3, right? And then, okay, let's see here. That can go underneath, right? That would be the 5th root of x cubed. No, 3rd root of x to the 5th. My bad. Our root is smaller than our power, and we have an odd root, which is nice. We don't need our absolute values then. Okay, so then we have negative 1 over 3. Okay, we have 5 factors of x. We need 3 of them, so that'd be x. And then we have square root of, cube root of x squared.
What did you do there?
I simplified this radical.
Oh, you took out x cubed.
Yeah, we took out x cubed, yep. It almost looks like x cubed the way I'm writing my radicals. Okay. The differentiation is not terribly tough, is it? It's all the extra rewriting garbage that we have to do, that we have to be mindful of. All right, this one. That's just negative 3 over 2. Is that it? There we go. X to the 0 power. What's x to the 0 power? That's just 1. So it's just negative 3 over 2. Okay. Questions on that? All right. last little examples. Rewrite using parentheses. Now, be careful when you're rewriting these. Sometimes you got to simplify first. Sometimes you don't. Just be careful. Rewrite, I would say y equals 5 over 2x to the negative third power, I think. Differentiate. Y prime. All right, we have our constant. Leave it there. Now let's use our power rule. Negative 3x, subtract 1, negative 4. And now simplify. Y prime equals, so negative 15 halves. And then x to the negative fourth, well, x to the fourth in the denominator. Sometimes I have a hard time writing across, so if you want to write vertically, that's just fine. Okay, rewrite. We got to be mindful what's going on. They're going to try and trick us with writing things differently. That's going to be 5. Now the whole thing comes up, right? It's either that, or I would distribute this third power to both items. So either that, or write it as 5 over what's 2/3. 2 to the third power is what, 8, and then x cubed. Okay, then we have 5 over 8 x to the negative third power. And remember, if it's a negative power, you can still just distribute to each item in that product. So then y prime, 5/8 times negative 3 x to the negative 4 power. And then rewriting the negative 15/8. And then x to the fourth goes downstairs. B and C are quite similar, but a lot different. We just don't have parentheses, so only the negative 2 is applied to the x for the power. So the rewrite's pretty easy. Y equals, I'd say 7/3 x squared. Maybe next, negative 1/2. Y prime, 7/3, 2 to the x to the 1 power. And then take care of your coefficients, 14/3 x. And then similarly with the letter D, use a rewrite, 7 times 3x squared now. And then we got 7 times, what is that, 9x squared, which is 63x squared. Notice I took a couple steps to rewrite. Do that, so it's a simple form for you to find the derivative. Y prime then, constant multiplier, times power, subtract 1 from the power. And then, was that 126? Much easier than the derivative, the limit definition of the derivative, right? Much easier. But make sure you're good at algebra, make sure you're good at rewriting, and make sure you're good at simplifying. Okay, those are big steps in the process.